My name is Srinivas Govada. I am working as an assistant professor in IARE college. Today we will discuss the CORD rules. He has framed 12 rules for any database to obey to be a good database. Okay. So let us get started. Dr. Edgar F. Card, after his extensive research on the relational model of database systems, came with the 12 rules of his own, which according to him, a database must obey in order to be regarded as a true relational database. So he has defined few rules, those are 12. So these rules must be applied in order to be a true relational database. These rules can be applied on any database system that manages the stored data using only its relational capabilities. This is a foundation rule which acts as a base for all other rules. So this is a foundation and it acts as a base for all other rules. Okay, the first rule is the information rule. That is, the data stored in the database, maybe it is user data or metadata, must be a value of some table cell. Okay, everything must be in a table cell, table row. Everything in a database must be stored in a database for table format. So any data must be stored in the table, and any data corresponding in that table should be in a cell. That is the first information rule. Second is the guaranteed access rule. Okay, every single data element, that is value, is guaranteed to be accessible logically with a combination of table name, primary key, and attribute name. No other means such as pointers can be used to access data. It says that everything can be retrieved by using a combination of table name. For select star from table name is a table name where the primary key, suppose where student ID is equal to 1. You want to, which column you want? Suppose example name. So it says that any single data can be accessible logically with the combination of table name, primary key, and attribute name. No other means such as pointers can be used to access the data. This is about the second rule, the guaranteed access rule. The third rule is systematic treatment of null value. Okay, in our database, we will have null value. Suppose we don't have any value to be supplied, so we will either we leave it empty or we will make it null. So the null values in a database must be given a systematic and uniform treatment. This is a very important rule because a null can be interpreted as one of the following. The null can be data missing, or data is not known, or data is not applicable. In this case, it says that we have to treat all the null values as a systematic and uniform treatment. You can't say one as empty, one as NA. That case should not be there. Okay? That is the third point, third rule. The fourth is active online catalog. The structured description of the entire database must be stored in an online catalog known as data dictionary, which is accessed by the authorized users. So suppose if the database is there, a user database is there, any column or table name will be available known in a system database data dictionary, which can be. This data will contain entire database structure of the entire database. Whether it is foreign key, primary key, constraints, index, everything will be recorded in that data dictionary. The user can use the same query language to access the catalog which they use to access the database itself. Okay? Like the user uses the SQL query to access the database, same way we can use the SQL query to access the data dictionary. Okay? Next, rule 5 is comprehensive data sub-language rule. Okay, a database can only be accessed using a language having linear syntax that supports data definition, data manipulation, and transaction management operations. This language can be used directly or by means of some application. If the database allows access to data without any help of this language, then it is considered as a violation. It says that the language used to access database will have a linear syntax and it will support data definition, DML, DDL, and transaction management operations. Okay. He also says that if the data allows access to data without help of this language, then it is considered to be a violation. It is not considered to be a good database. Sixth rule is view updating rule. All the views of the database which can be theoretically be updated must be also be updated by the system. It says that all the views which can be updated can also be updated by the system itself. Okay. Next, the seventh rule is high level insert, update and delete rule. A database must support high level insertion, updation and deletion. This must not be limited to single row, that is, it must also support union, intersection and minus operations to yield set of data records. The seventh rule says that the database must support high level insertion, updation, deletion, not for single row, but not only limited to single row, but also should support union, intersection and minus. Okay. Next is the physical data independence rule. The data stored in the database must be independent of the application that accesses the database. Whatever may be your application, but the data in the database must be independent. It can be a Java application, it can be a .NET application, but the data is independent. Any changes to the physical structure of the database must not have an impact on how the data is being accessed by the external applications. Suppose if there is any change in the structure, it should not have an effect on the front end application. Okay, this is the physical data independence rule. Rule 9 is logical data independence. Earlier we have seen physical data independence. Now we are seeing the logical data independence. The logical data in the database must be independent of user view. The logical data must be independent of the user view, that is application. Any changes in the logical data must not affect the application using it. For example, if two tables are merged or one is split into two different tables, there should be no impact or change on the user application. This is one of the most difficult rule to apply. One of the most difficult rule to apply is logical data independence. It means any changes to logical data must not affect the front end application. Okay. Next is rule number 10 is integrity independence. Okay. A database must be independent of the application that uses it. Database must be independent of the application that uses it. All its integrity constraints can be independently modified without the need of any change of the application. This rule makes the database independent of the front-end application and its interface. The integrity independence says that all your constraints can be modified without making changes to the application. This rule makes the database independent of the front-end application and interface. Rule number 11 is distribution independence. The end user must not be able to see the data is distributed over various locations. Your database might be at various locations, but the end user will not be able to see that. User should always get the impression that data is located at one site only. This rule has been regarded as the foundation of distributed database systems. We know in distributed databases, your database might reside at various places. Okay, but the end user will not have that vision thinking that he'll think it is only at one site only. The last rule is non subversion rule. If a system has an interface that provides access to the low-level records, then the interface must not be able to subvert the system and bypass security and integrity constraints. Okay, that means your interface must not be able to bypass security and integrity constraints. So your data is inconsistent. This completes the control rules. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.